So your question about hydroxyl groups and whether the bonds are going to be polar or nonpolar covalent bonds when we're looking at the skeletal formula, first I just want to review the skeletal formula. So this would be the same formula as this one up here. I've just got it expanded up here at the top. And so the points represent carbons, and then we know that every carbon is going to have 4 bonds around it. So if we're looking at this first one here, it would have another 3. That would give it a total of 4. This one right here is going to have 2 hydrogens. That would give it a total of 4 bonds. So we've kind of filled that part in. And then this last position down here where the hydroxyl group is at, this is really what your question was about. And when we're looking at this one, keep in mind that this is really saying the same thing as the oxygen with another bond to the hydrogen over here. Because oxygen always has 2 bonds coming off of it because it does have an electron configuration with 2 unpaired electrons. So this bond would be to the carbon. That's just kind of emphasizing this one right here. So when we look at this, here we have a bond, here we have a bond. In this case, this first one, this would be a polar covalent bond, and that's because the oxygen is strong, the carbon is weak, so we'd expect our electrons to be over here next to the oxygen. That make my oxygen a little bit negative, the carbon a little bit positive. And then we also have this bond on the other side, and this is going to be a polar covalent bond as well. So we'd have electrons over here, shifted over towards the very strong oxygen and away from the hydrogen, which is going to have a little bit of a positive charge to it. So just to sum it up, when we're looking at hydroxyl groups, usually this bond that would be here in the middle, this is kind of left out. It's just kind of understood to be there, and we simplify it by writing the O and the H right next to each other, but it is still there and it does still count as polar covalent bond. I'll just say while we're at it that if you saw it written in this direction, it's the same thing. There is still a bond in between the oxygen and the hydrogen. That would be your polar covalent bond. This on the other side is also going to be a polar covalent bond.